Imagine an object coming from another star system, crossing the cosmic void for billions of years, that suddenly starts to speed up when it should be slowing down. Not because of gravity, not because of the solar wind, but because of something that challenges our understanding of how comets are supposed to behave. Right now, at 250,000 kilometers per hour, something is escaping from our solar system, and it's speeding up in a way that shouldn't be possible. 3I Atlas showed signs of non-gravitational acceleration and shifted to an intense blue color as it passed by the sun. Think about that. An interstellar visitor that glows blue when it should be reflecting reddish light. That speeds up when physics says it should only slow down under the sun's gravitational pull. How can something gain speed in the vacuum of space with no propulsion? How can a dirty ball of ice shine brighter than our own star at certain wavelengths? We're facing a cosmic paradox. Order versus chaos. An object that perfectly follows the laws of orbital mechanics, but at the same time breaks them in fundamental ways. A Harvard professor calculated that the comet should have lost at least 10% of its mass to generate this non-gravitational acceleration. It's ice that burns, a traveler carrying the secrets of a distant star system, but acting as if it were being piloted. A darkness from interstellar space that now gives off bright blue light, the color of technology, of propulsion, of the artificial. But before we reveal what's really happening with 3I Atlas, we need to go back to the beginning. To the moment we realized we were no longer just watching objects that were born here. The comet 3I Atlas was discovered by the Atlas telescope in Chile on July 1st, 2025. At first, it was just one more point of light moving against the starry background. But something was wrong. Very wrong. The speed. When it entered the solar system, it was traveling at 58 kilometers relative to the sun, way faster than the two previous interstellar objects. Picture a bullet passing through a crowd. It doesn't belong there. It doesn't follow the flow. It's not part of the system. To understand what makes 3I Atlas so bizarre, you need to understand the basics about comets. Comets are basically dirty snowballs, cores of ice, rock, and organic compounds. When they get close to the sun, the heat makes this ice sublimate. It goes straight from solid to gas, creating the coma, that bright cloud, and the characteristic tails. But 3I Atlas is the third confirmed object coming from outside our solar system. The 3I means exactly that, third interstellar object. Its hyperbolic path means it's moving too fast to be captured by the sun's gravity. It's simply passing through. A one-time visit, no return. Then come the questions we can't stop asking. Where exactly did it come from? What kicked it out of its home star system? And why, out of all the comets ever observed, does this one act in such a strange way? Think of the solar system as a cosmic train station. Most objects are local passengers, going around on predictable routes. But 3I Atlas, it's a bullet train blasting through the station at high speed, coming from a city we've never visited and heading toward a destination we'll never know. So, what causes the acceleration of 3I Atlas? The first answer sounds simple. Outgassing. The release of gases. The main theory is that the acceleration is caused by mass loss. As it loses mass, it gets a little speed boost. It's like a party balloon being let go. The escaping gas creates thrust in the opposite direction. But that raises another question. How much gas is this comet releasing? Here's where things get really interesting. Observations from the James Webb Space Telescope showed that the coma of 3I Atlas is dominated by carbon dioxide with a CO2-H2O ratio of 7.6.1, one of the highest ever recorded in any comet. Wait, is that abnormal? Extremely. Most comets have way more water than carbon dioxide. But there's a problem. Think of the core of a comet like an onion made of cosmic ice. The outer layers are the first to sublimate when the sun heats them up. In normal comets, we expect those layers to be rich in water. But 3I Atlas is releasing CO2 as if it were soda being shaken up. The internal pressure forcing the gas out with surprising intensity. The comet was already active at 6.4 astronomical units from the sun, much farther than expected. That's because CO2 sublimates at much lower temperatures than water. It's like the comet started boiling while it was still far from the sun's heat. If this is true, then the core must be intrinsically rich in CO2, which means it formed under conditions very different from those in our solar system. Or it was exposed to cosmic radiation for billions of years during its interstellar journey, turning carbon monoxide and other volatile compounds into carbon dioxide. But here's the problem that's keeping scientists up at night. If we don't see a dense cloud of gas around the comet in December, cometary evaporation won't be the explanation for its non-gravitational acceleration. What if 3I Atlas isn't losing enough mass? What if the debris cloud that should be there just doesn't exist? Remember that weird blue color? For a natural comet, that blue color is really surprising. Dust should make the reflected sunlight look redder, and the surface of 3I Atlas should be about 20 times cooler than the sun's photosphere. The blue light suggests something very hot, or something artificial. This is where science hits the impossible. An object that should be cold shines hot. A comet that should be losing mass maybe isn't losing enough. An acceleration that demands an explanation, but whose natural explanations don't fit perfectly. Models show that a hardened crust 15 to 20 meters thick may have formed over billions of years, rich in CO2 and complex organic material. This protective layer, built atom by cosmic radiation, could be controlling how heat penetrates the comet's core, suppressing the sublimation of water while letting CO2 escape. It's a battle of scales, atomic-level processes determining the behavior of an object kilometers across. Billions of years of bombardment by cosmic rays resulting in a measurable acceleration today. The truth might be somewhere in the middle. 3I Atlas probably isn't an alien spaceship. Sorry, conspiracy folks. But it's also not a normal comet. Traveling at speeds of up to 250,000 km/h, it will soon disappear into interstellar space, never to return. It's a hybrid, a natural object with such extreme properties that it breaks our categories. An interstellar traveler carrying the scars of its epic journey. Let's go back to that object speeding through the cosmos. Now we understand. It's not alien propulsion, but it's also not ordinary comet behavior. It's the result of billions of years wandering between the stars, of exotic chemical composition, of protective layers formed by radiation, of a unique balance between CO2 and water. 3I Atlas will pass 167 million miles from Earth on December 19, 2025, then get close to Jupiter in March 2026, before leaving the solar system at the same speed it came in. What does 3I Atlas teach us about the universe? That every star system is a unique chemical lab. The observations match a core intrinsically rich in CO2, indicating that 3I Atlas may have been exposed to higher levels of radiation than comets from the solar system, or formed near the CO2 ice line in its original protoplanetary disk. We still don't know exactly which star system it came from. We don't know how many billions of years it drifted through interstellar space. We don't know if other objects like it are passing by unnoticed out there. What does it mean for humanity? That we're not isolated, that objects from other worlds visit our system regularly, that every interstellar visitor is a message in a cosmic bottle, carrying information about corners of the universe we might never reach. Think about how your understanding has changed in the last few minutes. We started with a mystery: unexplained acceleration. Then we learned about exotic chemical composition. Then we found out about cosmic radiation and protective crusts. And now we get that the weirdness of 3I Atlas is actually a window into cosmic diversity. The European Space Agency improved the predicted path of 3I Atlas by a factor of 10 using data from the ExoMars probe orbiting Mars. This unprecedented precision isn't just about tracking a comet, it's about getting humanity ready for the future. Because 3I Atlas won't be the last. Observations showed that the comet was already bright and active when it was about 6.4 AU from the Sun in May 2025, indicating that its activity is probably caused by the sublimation of volatile ices beyond water. For NASA, every interstellar visitor is a chance to test planetary defense systems, refine models of comet formation, and understand the chemistry of other star systems without leaving home. For us, it's a reminder that the cosmos is stranger, more diverse and more fascinating than our theories predict. 3I Atlas refuses to slow down because it carries the history of another world with it. And we, privileged observers, have only a few months to read that story before it disappears forever into the interstellar darkness. The acceleration isn't the mystery. The mystery is how many other visitors like it have already passed by without us noticing. And how many more will come, each one bringing its own impossible stories to tell. So yes, 3I Atlas refuses to slow down. But maybe the right question isn't why, it's what else are we missing out there?